Yes, good morning, class. Welcome to this session. Good morning to those who have joined in, and the others who have not joined in yet. Please join in fast. Today will be the third lecture on the chapter named Inspection and Quality Control. In this chapter, we had discussed about inspection in the first lecture, statistical process control and control charts in the second lecture, and in the third lecture, we will talk about acceptance sampling. Now, this acceptance sampling is a term that you have already familiar with. You have heard this term in the first lecture itself. In the last lecture, we have come across this term acceptance sampling of inputting of raw materials or of the output of finished goods. Now, in that lecture, we had covered what can mean the various types of inspection. One category was 10% inspection, and the other category was sampling inspection. Now, 10% inspection means where you inspect the whole lot, the entire lot is inspected before sending it to the market. And sample inspection is if you have produced a heavy lot of products, say 500 products, you sample out 50 of them or 10 of them, and if you find that your quality level is up to the mark, that is number of defectives is less than a particular set level, then you allow the lot to go into the market, or else you reject the lot or recycle the lot. That is the purpose of sampling, and that is the main objective of acceptance sampling. Whether you accept the sample or reject the sample, that is acceptance sampling. It helps in maintaining better relationships with the producer and the consumer. It helps in understanding your process quality level as well. So there are plenty of advantages of acceptance sampling. And moreover, if you cannot go for 10% inspection, maybe because the number is too much, maybe because of fatigue, maybe because of errors in inspection team that might be caused by this inspection team, or maybe because of destructive sampling, there are various reasons why you cannot really go for 10% inspection. Under that case, you have to go for acceptance sampling. So this is the basic idea about acceptance sampling. That is, you sample out a particular number from the whole lot. If it is within your set control limits, then you send it to the market. If it has crossed the limit and there are more number of defectives than your limit suggests, so limit can allows, then you don't send the lot to the market. Now, with this, we have got two important terms associated with it. One is average outgoing quality, AOQ, average outgoing quality or average outgoing quality level. That is, the formula says average number of defectives by number of items in the lot. So average number of defectives. What is the average number of defectives divided by divided by total number of items in the lot into 100. That is, you multiply it by 100 and you get it in a percentage number. That is what is AOQ. That is average outgoing quality level, average outgoing quality. And the second is AQL, acceptance quality level. Acceptance quality level is at the level that you have fixed for yourself. How much defects you will allow, that is acceptance quality level. Now, after doing all this, there are four cases that can emerge. Number one, You send to the market a good lot. That is a right case. You have done the correct thing, you have taken the right decision. Number two, you don't send to the market a bad lot. Again, you have taken the right decision. Number three, you send to the market a bad lot. That is a wrong decision. And number four, you don't send to the market a good lot. That is also a bad decision. Now, the first two decisions are okay, fair enough. But the last two decisions, that is, number one is you send to the market a bad lot, is a producer's risk. And you do not send to the market a good lot, is a consumer's risk. Try to understand. If a bad lot, by the means of sampling error, sample causes error, that is quite understood. By now you have understood that, and we have discussed this in statistics also in your previous semester. Sampling causes error, even if you are totally unbiased. Sampling error is there involved into the sampling process. Now, if in that error you unfortunately choose such a sample which gives you very good products instead of the entire lot being bad. Say, for example, out of 100 products in your lot, 90 are bad. But in your sample, unfortunately, you choose out of those 10 which are good. So that means what? You will think or feel that this bad lot is good, and you will send it to the market. What happens? The producers, the consumer is at risk. In this case, the consumer is at risk if you send a bad lot to the market. Now, if a good lot is not sent to the market, try to understand. If a good lot is not sent to the market, the previous one was a bad lot was sent to the market. So consumer, those who are consuming it, they will face a bad lot, which is a consumer's risk. Now, if a good lot is not sent to the market, just a second. Okay. So I was discussing about, there's some problem with the connection. Just hold on. Yes. We were discussing about, try to understand the two types of risks. One is producer's risk, one is consumer's risk. First is consumer's risk. A bad lot is sent to the market means, unfortunately, you have chosen such samples, such items, which are good from a bad lot. And you think, you feel that the lot is good. And you send it to the market. What happens? The consumers, the stakeholders are at risk. They will face a bad lot if you do that. And the other one is you reject a good lot. That is, the lot is good, but you have rejected it. Why? Because again, unfortunately, because of samples came out in such a manner that it felt like the lot is poor. Maybe out of 10,000 products, 2 are defectives. Now, when you are picking 10 items as a sample, those 2 items have come in. Now, you feel that the defective rate is 20%. So, a 20% defective lot cannot be sent to the market. So, this is a producer's risk. Producer have produced a good lot, but still the sampling error has not allowed the producer to send this good lot into the market. This is producer's risk. Now, these are same as type 1 and type 2 errors that you have learned in hypothesis testing. Type 1 error was rejecting a null hypothesis when it is true, and type 2 error was accepting a false null hypothesis, accepting a null hypothesis when it is false. So here also, producer's risk is rejecting a lot which is good that is type 1, and the second is accepting a lot that is bad, that is type 2. One is producer's risk, the other is consumer's risk. Now, this is shown by a curve called OC curve, operating characteristics curve. The operating characteristics curves looks like this. If I may show you, it looks like this. This is your operating characteristics curve. Here, this percentage is your consumer's risk, and this percentage is your producer's risk. In between, if you send it, it is fine. But if you send it beyond this, if the level of percent defectives is less than this, less than 0.95%, suppose you have accepted a quality standard of 95% accuracy. Now suppose it is more than 95% accuracy but still you reject the lot, it is a producer's risk. Now here, if the quality standard is less than 10% but still you have accepted the lot, it is consumer's risk. So this is an operating characteristics curve, and this is called the AQL, that is average quality level. This is the average quality level which meets the operating characteristics curve and gives you the producer's risk point. And this is the LTPD, lot tolerance percent defective, how much tolerable defective percentage you have. This gives you the consumer risk level. So I will share this operating characteristics curve with you. Please go through this operating characteristics curve. You will understand what kind of risks are there and what are the various terminologies. It is very easy to understand. Next is acceptance sampling procedure. Now in acceptance sampling procedure, we first have the lot is received, then the sample is selected, then the sample inspected for quality, results compared with specified quality characteristics, that has been previously told again. Now if the quality is satisfactory, you accept the lot and send it to the consumer or for production. Now I'm telling you here, consumer or for production means this acceptance sampling is carried out both for incoming materials as well as outgoing materials. If it is for incoming materials, you accept the quality and you send it for production. Send the material into the production house. And if it is for outgoing quality, after the inspection, you send it to the market to the consumer. Okay. Now, if the quality is not satisfactory, reject the lot or decide on disposition of the lot. Decide on disposition of the lot means what we will do with the lot, whether we will go for recycling or what, or entirely rejection or what kind of thing you are expecting to do with the lot. Normally, plants don't totally dispose of the lot which is rejected, because plenty of good items are also present in the lot. So if the entire lot is rejected, it's a huge loss of money. That is why there are several types of sampling plans. There are several types of sampling plans. The first one is single sampling plan. The second one is double sampling plan. And the third one is multiple sampling plan. In a single sampling plan, it is pretty simple to understand that either you set a limit, a quality limit, If your goods fall inside the quality limit or below the quality limit, you reject it. If it falls above the quality limit, you accept it. Or you set up a standard that these many products, if it is defective, up to this many products is acceptable. So if it is acceptable up to this, if up to that many products if it is defective, you accept the lot. If there is more number of defective, you reject the lot. It is simple in a single sampling plan. In double sampling plan, what you do is you set two standards, C1 and C2, cutoff point 1 and cutoff point 2. If it is below cutoff point 1, you reject the lot. Or if I reverse the saying, that is, if cutoff point 1 is number of defectives in the lot. If cutoff point 1 is your standard, that is below it you will accept it. That means if the lot is below cutoff point 1, see, this is a scale. Here you've got cutoff point 1, here you've got cutoff point 2. Now cutoff point 1 means up till this much defective you will allow. You will allow for up till this much. This is 0. You will allow up till this much defective. So if in your first sample you get defectives between 0 and this, you accept the whole lot. And what is cutoff point 2? If the number of defectives goes beyond cutoff point 2, you reject it. It's entirely rejection. So below this, accept, above this, reject. And if it falls between this, you sample it again. You take the second sample, the double sample. When you take a second sample, your cutoff point 2 remains the same. If in the second sample again, if it crosses cutoff point 2, you reject the lot. If it remains under cutoff point 2, you accept the lot. That is the double sampling plan. Now, multiple sampling plan is nothing more just an extension of double sampling plan. You keep on taking up samples until a final decision is adopted whether to accept the lot or to reject the lot. So this is the basics of acceptance sampling. So today what we have understood is three things we have learned. One is acceptance sampling, what it's meant for, how it is done. We have understood few terminologies like AOL, AQL, LTPD, producer's risk, consumer's risks. These terms we have understood what are they. Next, we have learnt about the operating characteristics curve, which gives you the producer's risk and the consumer's risk points exactly. And number 3 is the types of samplings, types of acceptance samplings: single sampling plan, double sampling plan, and multi-sampling plan. Now, with this, we end the lecture today. Please have the notes that I will share with you in your WhatsApp group regarding the operating characteristics curve. Please go through it very carefully. The entire portion of this chapter is very, very important. Nothing can be left out as unimportant, because inspection and quality control is one of the most important tools that decides the quality of the company. So this chapter needs to be understood and thought about very carefully, and a lot of research activities are going on this chapter on different types of different ways of inspecting goods throughout the world. So thank you, students. See you in the next class. Now you can give your exam, please. You can give your exam.